Applying rational functions. In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. A tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? So if we're talking about rational functions, what has to be true about at least one of the fractions? Where's the variable? It's in the denominator, right? That's what makes it a rational function, okay? At least one of the variables is in the denominator. So let's think about this. Okay, first of all, can we just back out away from the problem for just a second? Okay, I am trusting these civil engineers to know if one started here and one started here, they're not going to do this, right? I'm trusting them that they're going to do this. So I'm not worried about whether their aim is correct. We're worried about the time. Are you okay with that? Okay, so this first tunnel boring machine can do one job in 4 years. You okay with that? The second tunnel boring machine can do one job in 3 years. If they're working together, is it 2 jobs or is it still one job? It's still one job that they're doing together. How long is it going to take them together? X, right? That's what we don't know. Okay? Well, this seems a lot easier than the problems you did yesterday, right? When you were learning how to solve them. What was the first step in trying to solve a problem like this? Common denominator, right? So what would the common denominator for this problem be? Now, do we want to get a common denominator or do we want to get rid of the denominator? Get rid of it, right? Because if we have a choice, are we going to choose to deal with fractions? No, I want to get rid of them, okay? So I'm going to multiply each term by 12x. Because as long as I do it to each term, I haven't changed the problem, have I? Okay? So in this first problem, what happens? The 4 and the 12, right? They simplify. What do they simplify to? A 1 and a 3, right? So what's left here? 3x. In the second fraction, what happens? What does this simplify to? 1 and 4. So what's left? 4x. And then what happens here? X is simplified to, well, x is actually simplified to 1, but all that we have left is 12, right? Wow, that is super cinchy now, isn't it? 3x plus 4x is what? Try one more time. 7x, okay, 7x equals 12. How do I solve for x? X equals. How would I normally want you to write this answer? Yeah, just 12 over 7, right? We don't want to make it any more complicated than we have to, okay? But does that really make sense here? It says if both machines start at opposite ends and work at the same time, when will the tunnel be finished? Oh, and the tunnel will be finished in 12/7 years. What? That doesn't make any sense, does it? In this problem, what do I need to do? I do need to go to the decimal, don't I? Okay. Now, is 12 over 7 wrong? No, absolutely not. We know it's the correct answer. We need an answer that makes a little bit more sense to us in this problem. Okay. So what is 12 divided by 7? 1.71. I think it's a great idea that you went to 2 decimal places today. What is that called, by the way, 2 decimal places? The hundredth, right? So if on this worksheet today, if you have any questions, if you get to a point where you have to go to a decimal, how about if today we round to the hundredths? You okay with that? Okay. Now, this answers the equation. I need you to answer the question. And how do we go about answering this question? With a sentence, right? We have to write a sentence. So what did you say? The tunnel will be finished in 1.71 years. Is that the only way to write the right answer? No. Somebody else tell me another way we could have written it. It will take both machines 1.7 years. Would that make sense as well? Is that one even slightly better than this one? Why? Because we're talking about both machines, right? Okay. The tunnel will be finished in 1.7 years when both machines work together. Do you see the idea? Is this wrong? No, it is not. We answer the question, right? But when we're writing our sentence, we could write our sentence in such a way that it makes more sense in the problem. Does that make sense? All right, you ready for number 2? Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers per hour more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. So let's talk for a second. Let's talk about Tobias. Let's talk about Alicia. What do we know about Tobias? His distance is 300 kilometers, right? What's her distance? 200. And how fast is he driving? Okay, if he drives 20 kilometers faster than her, what do we call her speed? Yeah, we call her speed x, so that we can call his speed. Okay, I'm really glad you said that, because at first I thought you said 20x, and I'm like, he's not driving 20 times as fast as her. That would be deadly. No. Yeah, probably. Okay. Now, do you recognize this formula? What does that mean? Distance equals rate times time, right? What do we know in this problem? They went the same amount of time. What if I solved this problem for time? By dividing both sides by r, what does time actually equal? Over the rate. Wait, you mean I accidentally set up an equation just writing information down? Isn't this Tobias's distance? And then his rate? And isn't this Alicia's distance? And Alicia's rate? And what has to be true about them? Yeah, they have to be equal because the time are the same, right? How do I solve two fractions set equal to each other? Cross multiply. That's exactly right. Okay, cross multiply. So what is 300 times x? 300x equals 200 times x plus 20, right? What do I have to do on the right-hand side here? Distribute. Very good. Good vocabulary today, by the way. 300x equals 200x plus 4,000. How do I solve for x? If I subtract 200x from both sides, I get 100x equals 4,000. If I divide both sides by 100, I get x equals, how about 40, right? It's a good guess. You're on the right track, okay? This answers the equation. What answers the question? And I don't need your sass. No, I don't need your sass, because I know there's not a question mark here, so I know there's technically not a question, but you know what I mean. It's a statement, right? Find, what's it called? It's like a command, right? Find the speed. It doesn't say please find the speed. It just says find the speed. It's demanding you find the speed, right? How am I going to answer this? Alicia is driving what? 40 what? Kilometers, right? Kilometers per hour. And Tobias is driving 60 kilometers per hour. Does that make sense? How did you know it was Alicia that was driving 40? Yeah, we solved for x, and if you'll remember, we said Alicia was the x. Her rate was the x. So Tobias is the x plus 20, so we have to remember to add 20 to that to find out his rate. Does that make sense? Any questions on number 2? You good? You guys good? Think so? Number 3? Chef Craig can decorate a dozen cupcakes in half the time of Chef Charlotte. Together they can decorate the dozen cupcakes in 8 minutes. How long would it take each chef to decorate a dozen cupcakes alone? Before we answer this, I would like to apologize for not actually having cupcakes today. I know it's rude to talk about cupcakes and not have any to share, so please forgive me for that. Okay?
Tomorrow, right?
Not tomorrow. I'm not bringing cupcakes tomorrow. You can bring cupcakes tomorrow. That's fine. Yeah, that's your job now. Okay.
No.
Craig. Charlotte. Now, do you think this problem is more like number 2 or more like number 1? It's definitely more like number 1, right? Because aren't they working separately and then working together? Isn't that a lot like number 1? Okay, so we're going to set it up like number 1, right? What do we know about Craig? He's going to do one job for sure. And she's going to do one job for sure. And together they're going to do the one job. This is together. Right? What do we know? What is this? Where does that go? Underneath the together, right? 1 over 8, because they're doing that one job together, and together it takes 8 minutes. Now, we have a choice. We can deal with fractions or not. Except I know where we're going, so I'm going to choose on purpose to deal with fractions. I know. I have tissues right here if you're going to cry about it. You're going to be fine. Okay? If Craig can decorate a dozen cupcakes in half the time as Charlotte, what do we call Charlotte? X. And what do we call Craig? But he does it in half of the time. It's not the number of cupcakes we're talking about. We're talking about the time, right? You okay with that? Again, we're trying to get rid of the denominator, right? So what would be common between 1/2 x, and 8? What if it was this? 8x, right? It would be 8x. Does that change now that I have that? It does not. So I'm going to multiply each term by 8x. Okay? So what happens with the x's? They simplify. What happens with the 8? Well, what is 8 divided by 1/2? I need you to think about that. It would be 16, wouldn't it? 16. I'm going to write that for you so you can see it. 8 divided by 1/2. When I divide by fractions, what do I actually do? Sorry, 8. I multiply by the what? Reciprocal, right? Isn't it? Now, isn't it 16? Okay. What happens here? X is simplified to 1. And what's left? And what happens here? 8 simplified to 1. What am I left with? Oh my gosh. Yes. I didn't want to say it because I didn't want to jinx it, right? But since he said it, I'll say it again. So easy, right? Because hopefully you can figure out what 8 plus 16 is. 24 equals x. Now, would you please answer the question? Why did you start with Charlotte? Oh, That's who we called X, right? That's who we called X. So it makes sense if we start with Charlotte. It takes Charlotte 24 what? Minutes. Is that it? To decorate? Is that it? So period or what do you want? And, okay. And what? Why does it take Craig 12 minutes? He can do it in half the time, right? That's what it says right here. Half of the time as her. Takes Craig 12 minutes to decorate a dozen cupcakes. Good? Any questions? I'm going to take a quick commercial break. We've been talking about fractions this whole chapter, and I want to tell you something. Have you ever heard of A&W root beer? Yeah, it's delicious. We can argue about that later, but I will win. Okay? I am positive. First of all, because it's my opinion. And to me, my opinion is correct. Your opinion can be correct to you. That's fine. Okay? But A&W actually has a store, like a brick and mortar stores. Okay? And in the brick and mortar stores, they sell hamburgers. And several years ago, I would say many, but it's not many, unfortunately. Okay? They always served quarter pounders. So 1/4 a pound, right? That's what they always sold for their hamburgers. They decided they want to change it up a little bit and sold 1/3 pound hamburgers because those are bigger. That makes me super happy that you know that. Because what happened was that people freaked out because the 1/3 pound hamburger was slightly more expensive. And they could not figure out why they were having to pay more money for a smaller hamburger. And A&W actually had to stop selling the 1/3 pound hamburgers because they were losing money because people weren't buying them because they thought they were smaller. Wow is correct. So I think in general, people are dumb, right? Individually, you are geniuses, right? Some of you. Most of you, some of you. But people in general don't always have the best sense, right? Okay? So I want you to keep that in mind. We're going to go back to the show now, back to number 4, and I want you to keep that in mind as we start this problem. Okay? One pipe can fill a tank in 6 hours, while another pipe can empty it in 2 hours. If both pipes are open at once, how long will it take to empty the full tank?
Oh my Lord.
Uh-huh. So first of all, is this going to be more like problems 1 and 3, or is it going to be more like problem 2? 1 and 3, definitely, right? It's two things, except this time these two things are working against each other, aren't they? Okay? So instead of, what am I going to have to do instead? I'm going to have to subtract. So I know it's going to look like this, right? I know that this is one pipe, and this is the other pipe, and then this is together, right? How many jobs are they doing? Still one job. They're all doing one job. And if I'm trying to figure out how long it takes to empty the full tank when they're working together, what goes here? X. So I have to figure out what goes here. I have 2 possibilities, don't I? What are they? 6 and 2. I have to figure out what goes where. But I have to subtract the smaller one from the bigger one. So I have to decide which one's bigger. Right? It seems like the 6 is bigger, but you have to understand it's 1/6 and 1/2. Which one is bigger, 1/2 or 1/6? 1/2. So I have to say 1/2 minus 1/6 equals 1 over x. Does that make sense? Okay. Now what? Least common denominator, which was what in this case? 6x, 6x, 6x. Okay? What happens here? This simplifies to a 3 and a 1. So what's left? 3x. What happens here? The 6's simplify to 1. What's left? What happens here? Okay, can we take a really quick break? Because what I said to you the other day, when some of you were trying to cancel x's, I said, no, we're being ridiculous. We can't cancel x's like that, right? How is that different than what we're doing today? I don't have anything added or subtracted to the x's, do I? Everything that's to the x is being multiplied. That makes it a factor. I can simplify factors. I can't simplify things that are being added or subtracted to something else. Okay? So is it okay for me to simplify these x's? 100%, right? And x over x is what? Well, it's 1, right? So I have left is a 6. Now I have 3x minus x. 2x equals 6. Yes, yes, sir. Dividing by 2. X equals. Now, would you please answer the question? It takes 3 hours. That's it? To empty the tank. Empty the tank. Questions? I did half. You do half. Fair?